Hello, everyone, and thank you for joining us today. This is our HIMSS New York first ever podcast where we're going to be speaking with the author of, one of the authors rather, of Demystifying Big Data and Machine Learning. Prashant is with us, and we're going to go into a number of questions about the book, as well as learn a little bit about him as a person, his background. So, Mark, do you want to say anything before we get started with the questions?
Yeah, Prashant, thanks very much for taking this time. It's great to meet you. My name is Mark Russo. I'm here with Eric at Deloitte, and we also work together as part of the HIMSS New York chapter on membership engagement, and we've been looking at this book recently as part of our book club, so we're really excited to speak with you today.
Great. And
thank you, Eric and Mark. It's absolutely my pleasure to be here to talk to the membership of the HIMSS New York chapter. And it's very exciting to hear that we are the first book and the focus of your first ever podcast. Thank you so much for the opportunity.
Great. Thank you so much. And thank you, Mark Perlman, for making all this happen. Mark Perlman is also at Deloitte as well, and he contributed to the book. Mark, do you want to say a few words?
No, thank you very much for allowing us to be on today. This is a very important book for the industry. I'm glad Prashant could join us also.
Thanks so much.
Thank you, Mark.
All really exciting stuff. All right, so I'll just go into the first question. So just why don't you tell us a little bit about your background and how you got into the healthcare field for our listeners and our members of the chapter?
Sure. I have an undergraduate degree in chemical engineering, a graduate degree in technical communications and linguistics. So I think I've got some food for the thought going on for both my left and right side of the brain, or at least I like to think so. I'm currently Director of Product Strategy at Oracle Health Sciences Global Business Unit, based out of Pleasanton, California, where I'm responsible for a portfolio of health informatics products and solutions covering secondary use of data, integrated big and little data analytics, artificial intelligence, precision medicine, and population health. I'm also the chair of the 2018 Innovation Conference and Showcase for HIMSS Northern California, which includes the Silicon Valley. I have about 15 years experience as an emerging technology strategist, product manager, and expert consultant, with experience in strategy planning and implementation, market analysis and research, and serving as a trusted advisor to CXOs of healthcare providers, payers, and life sciences organizations. And that's my background. Getting into healthcare, I would love to say that it was my dream ever since I was 4 years old. And it was something that I was laser focused on, and that's what I decided to do. But in reality, it's a little more boring than that. I actually started in B2B e-commerce, and while it was pretty exciting, I wanted to do something a little more challenging and work in an area where I thought I could bring value not just to my users, but potentially also to myself. And healthcare is an obvious choice as a result, because all of us need healthcare, all of us will use healthcare, and whatever area of healthcare we are working in, the improvements that we can make here as a result of emerging technology can only benefit us and our families. So that was really how I got into healthcare after my initial foray in B2B e-commerce, and subsequently my career has included business leadership and management roles at Siemens, McKesson, Healthways, and MedicaLert, in addition to Oracle, where I've been for the last 9 years.
That's great. Quite an impressive background. And I know a lot of our listeners, some of them are still in college, and we'll be very interested to hear, your career path, and, for those of them who are interested in the B2B environment, business development is another place they can consider as well. So great. So the next question we had is around the whole buzzword of big data. A lot of the buzzwords, tend to lack substance. How do you convey its importance in the context of healthcare, especially for those of our members who, quite frankly, might be afraid of big data, or who lack technical understanding?
So as we have written at length in Chapter 2, there are a few foundational principles, Eric and Mark, that we need to deal with. The point that you make is absolutely valid. There is a lot of buzzwords, and unfortunately, there's also a bit of snake oil. So it becomes important to kind of recognize what big data means and recognize what it doesn't mean. So the foundational principles we talk about in the book are the following. Number one, being an industry or a domain determines what characteristics of big data matter to their users. In other words, what qualifies as big data in e-commerce is not necessarily automatically the same qualifier for healthcare or life sciences. To go make a final point, your average e-commerce company, Facebook, Yahoo, Google, etc., gather more weblogs and user logs and store and manage much more in terms of volumes of data than your average healthcare provider does on a daily basis. So what that means is volume is not necessarily a deterministic characteristic in healthcare. There are other things in healthcare that matter more than volume, and that's one of the things we talk about when we refer to the 3+2 V's of big data, and also make the point that not all the V's are equal. I'll stop there for a minute and take any questions before I go on to some of the other foundational principles.
You know, that's actually, I'm very lucky to have this call with you today, because I did not get it as clearly as I do now that you said it. When I was reading the book, I didn't, have that perspective, and putting it into perspective when you compare it to other industries, that it's absolutely a valid point. And just when you said it, it just clicked for me. So thank you for that. Great.
Oh, thank you. It also tells me I need to do a better job in the second edition.
Yes. No problem.
So moving on, the other foundational principles are our research for this book, which lasted more than 2 years and included interviews with almost 100 people, both inside and outside healthcare, clearly showed us that variety matters much more than volume in healthcare. And what that means is variety doesn't just mean variety in data sources. It just doesn't mean unstructured data or semi-structured data. Variety also means using this data to reach new use cases, to create new use cases, to reach new audiences that haven't been reached before, and to create new value for patients and providers and organizations in ways that haven't been done before. So when we take a look at variety in big data and take a look at this all-encompassing definition, it becomes pretty clear that the challenge in healthcare is not really one of volume, but more of bringing new and novel sources to accomplish a diversity in use cases and addressing more users than before. Veracity in healthcare data is extremely important because of two things. One is a large amount of healthcare data goes directly into patient care wellness. And what that means is the quality of the data, or as we will talk later, the fidelity of the data is extremely important, because we don't want to do something with a patient that's based on data that is suspect or inconsistent or incomplete. Veracity is important whether the data is little data or structured data, discrete data or big data, because the uses in which that data is used are still going to be patient care or financial wellness. So not having the right data in place could cause harm to the patient or to the financial well-being of your organization, both of which I think we want to avoid.
Absolutely.
And the last point we want to make here is that data fidelity is much more important than one-size-fits-all data quality. In the NRF framework in Chapter 2, we talk about these passionate debates that take place, I think, in any healthcare conference that all of us go to, which is you have one side of the house which says data quality is all important in healthcare, and until you get to this perfect idea of data quality, we shouldn't necessarily be doing anything with secondary use. And then you have some of the others on the other extreme of the spectrum who say that data quality actually doesn't matter. Well, look at all other industries. We take the data, warts and blemishes, and we figure out how to find value. So we shouldn't be spending time on data quality. We should really use technology to do the job. And I think this is a false dichotomy. And it's a false conversation in some ways, because I think what it does is it just allows people to dig in their position and entrench them. And when it makes for very entertaining panel discussions, it really doesn't help your average healthcare organization make sense of it all. So the point that we make in the NRF framework is data quality is always going to be a challenge. Data creation, unless it's coming out of a machine directly, a device or a wearable or a monitor, is going to be human created in some instances. And when humans are involved, to err is human. People are going to make mistakes. Mm-hmm. So trying to go after this ideal situation of data quality is not going to help us. Mm-hmm. We discuss instead the concept of data fidelity, which mm-hmm. is the appropriateness of the data in the context of its use.
Yes.
In other words, in some cases, what may not necessarily be acceptable in a clinical setting may be perfectly acceptable in an operational analytics setting, and or vice versa. Mm-hmm. So understanding that and being able to build that and acknowledging data fidelity as being the driver for big data and literal data is, we think, much more important than data quality. And these four foundational principles, we think, will actually make it easier for healthcare organizations to actually leverage the exciting stuff that's coming in the space.
Yeah, excellent. And I think that's a great point. And that was something that I had actually highlighted that I learned from the book at the time, reading it, just around data fidelity and the context with which the data is in. That's something unique, I think, as you said, to healthcare. So that's great. Thanks for that additional perspective. Okay.
And Prashant, I just want to build off of that, the foundational principles and the 5 V's. I was wondering if you could walk us through your approach to how organizations can leverage big data and data analytics to create shared value, sort of how they're going about this. Are there smart first steps, or how do they measure and define, those success stories?
That's a great question. So I think the key thing is to understand that boiling the ocean, in which we have an entire chapter dedicated to best practices and the myths of big data. And the reason we have a chapter dedicated to it was because we thought there was a lot of misconceptions in the space. And then the question really is, okay, forget those misconceptions. Of course, we want to debunk those misconceptions. But the key thing is
chapter 5.
Best practices that can be used for success. So a few things to consider in order to get to success over here is first recognizing the fact that the McNamara fallacy doesn't apply in healthcare. There has always been this thing that, okay, not everything in healthcare can be measured or measured accurately. And we posit that's because of the fact that we have not had enough data to do proper measurement. And with big data and little data and using them together, we will be changing that substantially. So I think it's time for us to first end the fallacy of the McNamara fallacy and move from there. Mm-hmm. The second thing that we talk about is some of the lessons here: determining purpose and scope, solving a pain point, creating a new opportunity for the business providers or patients, using more data variety or volume, not just volume. I think pretty foundational. I think they would apply in several instances, not just in this one. So those still hold good. At the same time, we also make the case that we have to be careful about the hammer-nail confusion. Big data is not a one-size-fits-all solution, and we shouldn't be afraid to say no to the latest big data technology, because not every use case requires big data management. In certain instances, your relational databases, data warehouses, smarts, BI may be the better or cheaper option for your next project than the latest big data technology just because it's available. Determining the benefits of the new technology compared to the cost of deployment, maintenance, and migration is a precondition to investing at scale across any enterprise. The last point there are several other points that we make in the chapter, but in the interest of time, the one other key thing is executive sponsorship is extremely important. Change starts from the top for any transformational exercise, such as this. And one of the consequences of datafication is the increased recognition of the need for either a chief data officer or a chief analytics officer whose team is responsible for all data and uses of the data across the enterprise. So team composition, skill sets, talent acquisition, management, and retention are going to be as important as any other technical factor or functional use case.
Great.
And Mark, I just wanted to call on you and see if you had anything to add on those points.
No, I think that Prashant really describes it from a very pragmatic point of view, and one of the great takeaways is certainly one size doesn't fit all, and data for one industry is not the same as in others. I think, especially in the case study that we wrote along with our colleagues from Deloitte, it was talking about a health plan and some of the reasons they went to more advanced big data type of solutions, and it really gets down to the fact that they had to transform their business, and as people do transform their business, they strategically have to look at not only the type of data they need to take in and start being able to review and do new interesting things with, but we're getting to a time that their regulatory reform and the way that healthcare is delivered is becoming and changing much differently. On one hand, a health plan can look at it from a population health perspective and wellness perspective. On another hand, they can look at it in terms of more advanced underwriting and really looking at how they can deliver care more efficiently as care becomes much more longitudinal versus episodic. We're getting out of a time of what I would call break-fix medicine. You're broken and we'll fix you, to a time where we really are trying to manage people for life and help them be to a system of health versus necessarily a system of sickness. And bringing in disparate variable data sources together will be part of the solution not only for health plans but providers. And as that data and the experiences and the episodes start to merge into a lifetime, these type of technologies are going to be absolutely vital. So this is a very valuable book for the industry, for sure.
Definitely.
Great. And actually, just building off of that answer, I want to skip to one of my future questions and ask you, how do we leverage existing analytics investments and go from analytics 1.0 to 2.0 and then 3.0 and so on?
I think the most important thing to do is to look at it with the end in sight. I'm certainly not a deep technologist that talks about which is the right appliance or which is the right device to use or whatever it may be. But I think that we've got to be able to figure out how to break down the silos and really look at it in terms of developing an interoperable platform. I think that we've got to be able to have secure and accurate ways of doing patient matching and across various disparate systems, and we have to start looking at it from a systematic approach. And the data will not necessarily be residing in your organization. The question is, how do you bring that together not only into the insights, but to make healthcare much more proactive? And that's going to be a lot of it's going to be interoperability and technology, but then a lot of smarts to be able to do the predictive capabilities to really make a difference in the cost curve.
Okay. Yeah, absolutely. I think that's great points made, and agree loud and clear on that. So just kind of going back to the scripts, to the script that we wanted to outline. Just want to talk more, back up a little bit and talk about some of the risks associated with deep learning itself and with predictive analytics, and how do we alleviate some of the concerns around privacy. I know specifically in the provider space, privacy is a big concern, as well as overly automating processes in the healthcare industry. What are some of the risks, and what are your thoughts on those? And this, for Prashant or Mark or either.
So I think going back to a point, and sorry if I sound like a broken record on this, and I don't think this risk is particular to deep learning or predictive analytics, though there are a few which we will talk about here. I think the primary risk that we face right now is how do we democratize big data, machine learning, and AI, and move it, as any emerging technology should, from the places where it is practiced, where lots of expertise is required, and move that to professionals today through tools and training and support mechanisms that allow them to incorporate some of this in their daily jobs. So I don't think the answer lies either in educating enough data scientists, because I think if all the universities, I read recently, that if all the universities basically shut down all their degree programs and only did data science across the whole world, we still would not have enough data scientists to go around, considering the explosion of data that's coming. So obviously that's not an answer. So we just can't educate or skill set our way within the next 5 years, for example, to get what we want. So what's the other option then, right? Because the opportunity is there, and the biggest risk, in my opinion, is healthcare is not able to take advantage of it, because we don't have the right skill sets available across organizations, not just the large organizations, but also the small and mid-sized ones. And the way I think we democratize AI and democratize machine learning is to allow people who are business analysts and technical analysts and architects and executives today, and help them bring the ivory tower language and the Mathematica to a level, plain English, where they can understand, and more importantly, they can use it and leverage it in their daily work. And that's how we democratize it, because we often hear about democratization of AI. That phrase is meaningless, because unless you are able to bring it down to your own colleagues, forget democratizing it to average Joe and Jane.
That's really interesting. Yeah, that's a powerful point.
Data science-specific risks, in my opinion, are some classic ones. The primary one being that correlation is not causation. So one swallow doesn't make a summer. And you know what? Even a group of swallows that's lost and that's on your roof now doesn't make a summer. So understanding the difference between correlation and causation is still important, because, again, it doesn't come down to the fact that people don't understand the meaning of the terms. It's just that when you're taking a look at insights, if you really don't understand what's driving that, including the biases of the humans and the machines driving it, there's a very real chance that people mistake the two and take decisions that may not necessarily be accurate. The other thing that we should do is a big risk is folks sometimes get enamored by accuracy or performance of a specific algorithm, and because they get 90% performance in the algorithm, they want to go with it. But it could be that there is a problem with the algorithm, or there's a problem with the data. So the key thing is to try many algorithms, try ensembles, try more than one algorithm on the same data set. And also at the same time, always treat your data with suspicion. If the results are too good to be true, chances are they are.
Great.
And then the other thing is, while we focus on data fidelity, as we discussed earlier, on the uses of the data, we must also ensure the quality of the training data set. And two other topics is related to this is human feedback loops. In healthcare, human feedback loops are extremely important. Downstream users can provide feedback on when algorithms get things right and get things wrong. And we should be focusing on how we are capturing this feedback from humans so that we can bring it back into the training that happens. And this is great for false positives, but can miss false negatives. So you'll want to pay special attention to false negatives as you train, and use this experience to find missed results in production data review and include them in the next round of training. In healthcare specifically, without human feedback loops, especially from clinicians or from executives, things are going to be really challenging to move things forward. Finally, also related to the same thing, is healthcare doesn't trust black boxes. Black boxes and black box systems, machine learning systems, work great if, well, I wouldn't say work great, but work acceptably so. If you're trying to recommend the next DVD you should watch or the next product you should purchase. Black box doesn't work very well when you're telling a physician that the diagnosis is so-and-so, the comorbidity is so-and-so. You need to operate on this patient now. That requires a white box treatment. And I think that's the final point on this topic.
Absolutely. That's a good point. We definitely don't want our doctors to prescribe medicine to us based on a black box. We want to understand those comorbidities, as you said. So just kind of building on a point you made in your response to the previous question around data quality. data quality can be challenging with little data, but our key to veracity, it's one of the 5 V's that you talk about in the book. How do you propose we manage data quality with vast, fast, and varied big data?
I think, again, the answer to that is very clearly data fidelity. And in order to do that, we need to examine data quality for what it is today, right? And again, having spent a few years of my life building systems to validate and manage data quality, and more importantly, looking at how that changes business success and ROI, I would be the last person to say that data quality doesn't matter. At the same time, I think it's high time for us to move past this one-size-fits-all data quality for little data, where you know what are the allowable values for every single attribute and what you need to do to get things there. And again, as you said yourself, Eric, that has been a relatively spotty exercise, not just in healthcare, but even across healthcare, as we see in news stories every once in a while.
Yep, absolutely.
So really the conversation has to move towards data fidelity, which is how appropriate is the data in the context of its use. And the 3 key words there are appropriate. So we are not asking for perfection.
Mm-hmm. Yeah.
What we want to know is the data good enough to be used. Mm-hmm. And the second key word is use. So in other words, we don't care about the quality or not until the data is ready to be used or we know how the data is going to be used. So we are not going to be spending time and effort on all the big data that's coming in trying to meet some illusionary unicorn situation until the data is ready to be used. And the third piece is context, because the same piece of data, the same analytic could be interpreted by 2 different users or user communities in 2 dramatically different ways, as we often see in healthcare, where semantics are similar but also differing. And in that case, we have to acknowledge the same as well.
That's great. And I think you made some great points there. You talked about the context and keeping that in mind. So for the next question, I wanted to ask you, what are AI contextual intelligent agents, and how are they related, if at all, to data and machine learning?
That's a very good question. So again, we are still in the nascent stages of big data, machine learning, little data, AI, and I don't see these as separate. I see them all interconnected. First, it's about all data. It's not about big data. It's not about little data. It's about big and little data, bringing them together, using each and getting more value than we get out of it today. That's the key thing. So data is the lifeblood of the pipeline, so to speak. Machine learning is a data-intensive method that uses learning algorithms in order to essentially generalize things, and then also in order to predict, and used as a basis for prescriptive and predictive analytics. One of the things that Bob Rogers and I, my co-author on this chapter, we looked at extensively was, okay, fine. I mean, most industries, not just healthcare, but outside healthcare, we know are in a situation where they've got a huge amount of machine learning going, depending on which industry you're in. But the key thing that we saw again and again was that it's not really about data or data-intensive methods. The most important thing is context. And we write that in Chapter 7, that machine learning and big data and little data will only begin to recognize and realize their full potential in healthcare when these contextual intelligent agents are put into widespread use. So what is a contextual intelligent agent? It's basically a system, an AI system, that can interact directly with a human via spoken or written communication, and that can understand context to identify what's important in a given situation. We say that CIAs are the first and crucial stop on the journey to artificial intelligence. So the question then is, why is context so important? Well, most machine learning algorithms have been created to answer a specific question. How can I compare 2 patients? Is this a heart failure patient? When will this patient convert from pre-diabetes to full-blown diabetes? But for any given situation, there are many, many questions that can be reasonably asked and then answered. But intelligence in a machine learning context and in an AI context depends in part on the ability to know which question to ask at which appropriate time based on the context of the situation, who is asking the question, what has changed, where is the question being asked, why is the question being asked, and so on and so forth. So these systems that are able to sufficiently be aware of context to be able to ask, and most importantly, answer the right questions we call CIAs or contextually intelligent agents.
Great, and I think that's very interesting. I remember taking a pause when I was reading this chapter 7 to post onto the LinkedIn group about this one. Chapter 7, Applied Machine Learning for Healthcare, and I really love the quote you have on here from Pablo Picasso: "Computers are useless; they can only give you answers." So, yeah. So yeah.
There was a bit of interesting thing about whether that quote was actually real or not.
Oh, okay.
And as I've shown there from Quote Investigator, it is a real quote.
Oh,
and I think it's finally we can show Picasso only after about 60 years that computers are useful after all.
Yep. Hey, I wish we could speak with him and tell him. Great. Great. Okay, so I think that was really all we had. Is there anything else that I didn't ask you today, that Mark and I didn't speak to you about, that you'd like to share with our listeners?
I think we covered a lot of ground here. I don't think there's any specific points here in addition to the ones we discussed here as key salient points for people to think about. I think we hit upon several ones. We, of course, encourage folks to read the book, and specifically the case studies, because it's easy to opine.
Yeah.
And as an author, well, by nature, we opine. But what's more important for healthcare is to bring real-life case studies that have been validated, that are in production, that have shown success, to demonstrate the points that we make. So we have 8 case studies in the book, so I would encourage all our readers to spend some time reading those case studies and relating it back as they see fit to the previous 7 chapters.
Absolutely, definitely. That's something that we all looked forward to. I think that's probably one of the reasons that we selected the book, is just because we were all, we kind of got ourselves educated up in the front, and then, we're happy to dive into those case studies at the end. So definitely agree with you 100% there. So
I'd also just like to thank you again for this opportunity, to HIMSS New York, to the Deloitte team, to my employer Oracle for letting me participate, and then to my friend and mentor Mark Pullman, with whom it has always been a pleasure to collaborate, and this book is only the most latest manifestation of that.
Thank you, Prashant.
That's great. Thanks so much. And again, I also want to thank you guys for making the time to do this today. Mark for making it happen and making the introductions. Prashant for taking the time out of your busy day at Oracle, and Mark Russo, who's here as well, who's doing a lot of interesting stuff with your clients. So this is really good, really exciting, and I think that everyone who's a member is going to just be so thrilled when they see this publication posted.
Thank you so much, Eric and Mark, and those are great questions. I really appreciate the fact that you took the time to read the book, and it's awesome. And thank you for your kind feedback, and if there's any way that I can serve your membership, happy to do so.
Absolutely. We'll definitely have to keep you in touch, and let's keep the conversation going. Absolutely. We'll definitely be in touch. So this has been a great treat for us.
Yeah, thank you.